Good morning, everyone. I am Mrs. P. Lanka, Assistant Professor from the Department of Electrical and Electronics Engineering. In this presentation, we will discuss the different types of electric generators used in wind energy conversion systems under the subject Power Electronics for Renewable Energy Systems. We will learn about the operating principles, components, advantages, and applications of various wind turbine generators. In wind In wind power plants, different types of generators are used depending on the required power capacity, efficiency, and speed control characteristics. The wind turbine converts wind energy into mechanical energy. This mechanical energy rotates the turbine shaft, which in turn drives the generator rotor. The major generator types are squirrel cage induction generator, doubly pet induction generator, wound rotor synchronous generator, permanent magnet synchronous generator. To improve generator performance, yaw control is used. Yaw control continuously aligns the turbine toward the wind direction, maximizing energy capture and increasing power output. The slide introduces the different generator technologies used in wind turbines. The concept of yaw control shows how turbine orientation affects energy extraction. This slide shows the block diagram of a squirrel cage induction generator. Wind energy rotates the turbine blades through a gearbox. The rotational speed is increased before being supplied to the SCIG. The generated output is connected to a back-to-back AC to DC to AC converter system. This converter helps regulate power before applying it to the grid. The capacitor bank is connected for reactive power compensation because induction generators require reactive power for magnetization. Finally, the generated voltage is stepped up using a three-phase transformer and supplied to the utility grid. The turbine plates captures the wind energy. The gearbox increases the rotational speed. The CIG converts mechanical energy into electrical energy. The AC to DC to AC converter controls power flow. Capacitor bank supplies reactive power compensation. The transformer is used to step up voltage before grid connection. Grid is used to receive the generated electrical power. In the SCIG system, power control is achieved mainly through aerodynamic methods such as pitch control and yaw control. A capacitor bank is connected across the lines to compensate for reactive power demand. This improves the power factor and enhances active power delivery. The stator output of the generator is connected to the grid through a back-to-back power electronic converter. Before connecting to the grid, the voltage is increased using a three-phase step-up transformer. This slide illustrates the wound rotor induction generator like the SCIG system. Wind energy rotates the turbine plates. The gearbox increases the speed and drives the wound rotor induction generator. Unlike SCIG, the rotor contains windings connected to an external resistance circuit. By varying this resistance, the slip of the generator can be controlled. This provides better speed regulation and improved energy capture under changing wind conditions. The generated electric power is transferred through transformers and finally delivered to the grid. The main components of this system: wind turbine blades, gearbox, WRIG, variable resistance unit, capacitor bank, transformer, and transmission tower. This slide shows the wound rotor synchronous generator, which is variable speed generator. The rotor winding is applied with a DC excitation through an exciter. This creates the magnetic field required for synchronous operation. The generated AC power is converted to DC use DC using a rectifier. A DC link stores and smooths the power. An inverter then converts the DC power back into AC with the required voltage and frequency. Finally, a three-phase transformer increases the voltage level before power is supplied to the grid. The WRSG offers several advantages in modern wind energy systems. It provides independent control of active and reactive power through power electronic converters. It is suitable for high power applications and generally offers higher efficiency because gearbox requirements can be reduced or eliminated. The power factor is better, and during grid faults, the stator can be isolated quickly to protect the system. However, WRSC also has some disadvantages. It requires a DC excitation source for the rotor field winding. Mechanical balancing is more complex and maintenance costs are high compared to simpler generator types. Thank you for your attention. In this presentation, we discussed the major generator types used in wind energy conversion system, namely SCIG, WRIG, and WRSG. Along with their operation, components, advantages, and applications, I am happy to answer any questions. Thank you.